This is the 13A video. Uh, let's see. This week we're just gonna review what we learned about last week, and then we're gonna talk about our new topics. There are assignments this week. There is a homework assignment. There's a notebook check on there, and there is the activity that all of that will be due at Friday at 11:59 p.m. The only announcement is that I will not be there on Monday, April 13th, but everything will be posted on Google Classroom, and you will be able to start taking notes. And I never put a big question of the day up there on this one because I just put Isaac Newton up there because he did the best work during his quarantine. So just to remind us that we can still do some learning. So remember, there's a weekly plan that is subject to change, obviously. But Monday is more of an introductory notes and what time to watch the videos if there's time. Tuesday is that first lesson. Wednesday is that second lesson. Thursday is going to be a lab day. Friday, miscellaneous homework, but subject to change depending on like whether the labs need to be done first or we run over on a certain day. And every week there will be 3 assignments for you to do: the lab activity, the homework assignment, and the notebook check. And their weekly task list, just watch those 3 videos. And I've decided that if you're there on Friday, what I'm going to do is I'll give you the codes in class because you probably haven't watched the videos yet, and you've probably been there all week, and you are ready to do the homework. Notebook check, and there will be an activity that will be done in class, and there is also a homework assignment. The codes in each video, one will be a written code on the screen, the other will be a verbal code said by myself. Each code will be 3 numbers that are randomly generated. There is no way to predict them. All right, so let us review. We learned about the fundamental forces of the universe. We learned about the strong force is the force that holds the nucleus of an atom together. It is the strongest force. Its range is about the width of the nucleus of an average atom. The electromagnetic force is the attraction or repulsion between positive and negative particles. It is the only force that repels. It has infinite range. The weak force is responsible for radioactive decay. It is the shortest range of any force. Its range is about a tenth the width of a proton. So while the strong force had the range of about the average nucleus, if you zoom in, the weak force has the range of a tenth the width of a proton. All right, and gravity is the weakest force, and if gravity is the attraction of all mass, its range is infinite, and you can see here that if the strong force was number 1, well, gravity would be 0 point and followed by 38 zeros and a 6. So this is the chart that I had you make in order to take the notes for the fundamental forces. And those are the links for that day. Now, then we learned about the history of the atom, and it started with Democritus and the idea of atomos, which means uncuttable, in the year 400 BC. And he proposed that atoms are infinite number, uncreated, eternal, and the qualities of an object result from the kind of atoms that it is made from. So we did a lab of how can we see something too small to see, and that's Rutherford's gold foil experiment. So what this is that alpha ray particles were shot at a gold foil, and what they expected was that all of them were going to go through. However, not all of them did. 1 in 8,000 were deflected in some way, and using this, Rutherford was able to determine the size of the nucleus of a gold atom. And this is what we did in the gold foil experiment, where what the lab was, you would launch pennies that represented the alpha ray particles down to the masses, which represented the gold atoms, and using that equation, calculate the diameter of those masses. And this was the history of the atomic theory. If you wanted to look at the notes on the slides, I've posted all of them. But see here, it went from John Dalton to 1803 all the way up to Erwin Schrödinger into 1926. All right, we learned about the parts of the atom. So the nucleus is the center of the atom. It contains the protons and the neutrons. The electron cloud is the area surrounding the nucleus where electrons are found. The proton is a positively charged particle in the nucleus. The neutron is the neutral particle in the nucleus, and the electron is a negatively charged particle located in the electron cloud. So we did build an atom simulation where you drag the protons, neutrons, or electrons into the atom, and then you determined what that changed. All right, then we talked about how to identify the atom. So the atomic number, which is that bottom number, identifies the element, and it is the number of protons. So in this one, sodium has 11 protons. If it didn't have 11 protons, it wouldn't be sodium. The mass number is the number of protons plus the number of neutrons. So you can see here that's that top number, and the mass number is 23. The charge is the overall charge of the atom. And you can see here in the sodium, it does have a charge, which makes it an ion. So it's an atom with a net charge due to the loss or gain of electron. And an isotope has the same number of protons, different number of neutrons. It would be the same element. So it would have the same number of protons, but the mass number would be different because it would have different neutrons. So problem that you'd expect to see is the atomic number. Well, this is going to be 3, and the mass number would be 7. Well, I know that the number of protons will be the atomic number. That is 3, and it's going to have 4 neutrons because the mass number is 7 minus 3, and what's left over is 4 neutrons. The net charge is going to be 0, so that means I'm going to have the same number of electrons as protons. I have 3 protons, so that means I have 3 electrons. So you can see here I had a lot of links on this day. There was a lot of videos that I played, but well, I didn't play all the videos, but if you want to, you can take a look at some of the ones that I did not. That'll help you out understanding the material. And this is the written code for 13A. I would recommend writing this down somewhere. All right, now what are we learning about this week? All right, so we're going to be learning about states of matter, electrostatics, and the triboelectric series. So at this time, I'm going to go ahead and give you the verbal code. It is 280. I'll say that again. The verbal code is 280. So this is the states of matter video. This will help you about electric charge and different types of charging. This does a good job of showing charging like in real life. And this talks about the triboelectric series. Now, the videos that we're going to do, or the labs that we're going to do are Revenge of the Pith, so a little play on the Star Wars title, and we're going to do the static cling lab. So very similar labs, but just a little bit different. They give us a little bit different data. And there are the links for today. You can see here there's a lot of simulations. I recommend looking at the resources or the activities and simulations because that'll help you understand all those charging. And as always, I leave you with my final thought. There's just too much unknown in the universe to take a break from learning. Get out there and question everything.